All right, so in this third video, we're still talking about estimation and confidence intervals, but now we're going to be estimating a proportion or estimating P. So our point estimates for P and Q are what we call P hat or Q hat, and it is our number of successes over our total number of trials. So what you can see down here is defined. Our error formula is just a little bit different. The ZC, we are using our confidence level tables just like we had. I'll pull mine up over here. If you remember this one right here, it was this confidence interval. So if I wanted an 85% confidence interval, my ZC would be this 1.44. But we used that at the very beginning when we knew sigma, when we were estimating the mean. But now we're estimating proportions, and we are going to use the Z critical values again. All right, and here's the breakdown of how the confidence interval works. So we're going to find our error, which these two formulas are the exact same thing. One of them just uses Q, and the other one says, oh, instead of writing Q, I'll just write 1 minus P, because that's the exact same thing. But once I find that error, I'm just going to add and subtract my error from that P hat, and I can estimate what the actual population proportion would be based on a sample proportion. We'll come back to this. This is, once again, if we're going to estimate a sample size. If we don't know the sample size, but we kind of can guess at the proportions and what error we want, we can figure out how big a sample we need to draw. All right, let's do an example here. Suppose that 800 students were selected at random from a student body of 20,000 and given shots to prevent certain types of flu. All 800 students were exposed to the flu, and 600 of them did not get the flu. Let P represent the probability that the shot will be successful for any single student selected at random from the entire population of 20,000. Let Q be the probability that the shot is not successful. All right. So we need to know what is our N. So N and R deal with our sample. So, and we want to compute a 99% confidence interval for P. All right, so our N is our sample size. So that's going to be our 800. We had 800 students that were selected and given shots to prevent it. R is how many of them did not get the flu? Well, that would be 600. So to figure out P, we would do R divided by N. So we would do 600 divided by 800, which if you actually divide that, that would end up being 0.75. So it had a 75% effective rate in that sample. That means Q would be 1 minus that. So we'd have 0.25. So to find our margin of error, if you recall, it was ZC and then P, Q divided by N, and all of this was under the root. And in case you don't remember that formula, let me go back one more. Here it is right here. ZC, P, Q, and all under the root. All right, so we want a 99% confidence interval. So let's look at this table, and 99% is 2.58. That's our critical value. So 2.58. I'm going to do a big root here. So our P is 0.75. Our Q is 0.25. And our N is our sample size, which is 800. So that's what we're using to estimate our margin of error. So 2.58 times the square root of 0.75 times 0.25 divided by that 800. All right, my estimation of that is 0.039. All right, now to actually figure out the interval, or the confidence interval, we would P hat minus E, and then P hat plus E. We found our P hat to be 0.75, so we'll do 0.75 minus 0.039. And over here, we'll do 0.75 plus 0.039. All right, I'm going to change colors here so it doesn't get mixed up with the other work there. Excuse me. So we have 0.7 1, 1. This is P now, not mu. And then 0.789. So this is our 99% confidence interval for P. Basically, we're saying that the success rate of the shot for 99% of the samples would be between 71% and 79%. All right, now we're going to talk about what happens if I don't know the sample size and I have a specific error I want to stay within, and I have a confidence level, and I want to figure out how many I have. All right, so if I have no preliminary study, that means I don't have any idea what this p-hat is. All I know is I want to be 95% sure that I'm within 0.01. What that tells us here is that I want my E to be 0.01. But I know this 95% confidence interval. So this goes back to this one right here. So if you have no preliminary estimate, it's this formula. If you have a preliminary estimate, it is this formula. So kind of keep those in mind. So for this one right here, with no preliminary estimate, 1/4 ZC over E squared. So we got to find our ZC for 95%. I'm pretty sure that's the right formula. Yep. So our ZC for 95%, I can look at this again. It's 1.96. So I've got 1/4 times 1.96. I know my E within the problem is this right here. I'm going to square that. All right, and so I'm going to do all that. So 1/4 and I got 9,000, and it says always round up. This did come out as a nice number, but we are going to round it up. So I got 9,605. So probably should read the problem to make sure this makes sense. So a company is in the business of selling wholesale popcorn to grocery stores. The company buys directly from farmers. A buyer for the company is examining a large amount of corn from a certain farmer. Before the purchase is made, the buyer wants to estimate P, the probability that a kernel will pop. Suppose a random sample of N kernels is taken and R of those kernels pop. The buyer wants to be 95% sure that the point estimate P cap for P will be the error either way of 0.01. So probably need a large sample, especially if we don't know a preliminary estimate. So we can actually look at that a little bit better. Okay, so now we're going to say what happens when we have a preliminary estimate. We're going to go through and do the same thing. Our error is still the same. So our error is still 0.01, but now we have to use a different formula. So we are using this P, 1 minus P, and then ZC over E. So our ZC also didn't change. So N equals P, 1 minus P, ZC over E, all squared. Well, this right here, this is our P. Our ZC is still that 1.96 from above. So let's actually plug all these numbers in. So I'm going to have 0.86, 1 minus that, which would be 0.14, then 1.96 over 0.01 squared. So just think about it. If I know a preliminary, do you suppose I need as many kernels, or am I going to have more? So just think about it and kind of make a guess and see what thinks is going to happen here, and then check and see if you're right when we're done. So rounding up to the nearest whole number, we're going to get 4, 6, 2, 6. So almost cut it in half. Actually, over, then cut it in half. So really having the preliminary does make a huge difference. So hopefully this helped, and good luck with these as well.